Okay, children, so we start from where we left. We were talking about the scan chain design, and we said that the problem of sequential circuits can be easily solved if somehow I can represent my sequential circuit in the form of a combinational circuit, so that I can apply the D algorithm or the Boolean difference ATPG algorithm for the combinational circuit directly. We saw two approaches here. The first approach was to use a flip-flop or to convert a flip-flop with the addition of set and reset pins. And the second option was that you configure your flip-flops in the form of a scan chain. Scan chain in the form of shift register. When we use this set reset pin, तो जो नॉर्मल मेरा फ्लिप फ्लॉप था जिसमें केवल एक D इनपुट Q आउटपुट था and there was a clock. So three pins were required, two inputs D and clock and one output pin Q. But now when I use a set reset pin, in order to control the value of Q directly, I have added two more input pins. So for one D flip flop, I have added two pins. So if we have 10,000 flip flops, I'll be adding 20,000 pins more at input. हर flip flop का set reset अलग काम करेगा. Therefore, the number of input pins is drastically increased. I do not want that, so that I can have lesser number of pins along with the possibility of ease of testing the sequential circuit. We used scan chain, where we said that input is D, I have a test control signal TC, and I have another input scan in along with clock. क्लॉक तो है ही, डी भी है और स्कैन इन आ गया एंड नाउ आई हैव द आउटपुट. This TC is used to control the mux which lies inside this D flip-flop. When I have that TC set into scan mode, test control is scan mode. If I put it in scan mode, whatever data I put in here enters into the D flip-flop and it goes at Q. This happens at one flip-flop. Then the output of this Q goes to the scan in of the second input and I have another Q. D iska alag rahega. So the chain is set up. So how many total number of inputs did I add? I added only one input irrespective of the number of flip-flop. Jitne bhi flip-flops honge, these are connected in the form of shift register. So the number of inputs that are now added is only one. However, I'll need more clock cycles. How many clock cycles we will need? We'll need the clock cycles equal to the number of flip-flops. Right? These flip-flops are now called the scan flip-flop SFF. Fine. Number of cycles क्यों चाहिए? Because this is a shift register. Suppose I enter the first value 1 here, then at the next clock edge, this 1 will be propagated to the next flip-flop. एक अगर और आगे लगाना और आगे पास करना, then I'll need another clock cycle. Therefore, I'll need more number of clock cycles, but the number of input pins is only one which I have added. So now we look at this thing in the form of circuits. This was the circuit that we did in the previous class when we were talking about the normal testing for sequential circuit using the time frame method. Now if I have a set and a reset pin added to my D flip-flops, what is the ease that I got? If I want to transmit this fault stuck at 0, it means actual value is 1, faulty value is 0, so a D is seen here. This fault D will be propagated only if I have the value here as 0. Right? To have a 0 here, I need to have 1 here. To have 1 at the output of D, I need to have the inputs at 1. So A becomes 1. The output of flip-flop is required to be 1 here. The output of this AND gate at the input will be 1 if I have both the inputs as 1. So in the last time frame, I should set C equal to 1 so that it is propagated as 1 here. Now the advantage that I get using this set reset is now we need not work for different time frames. I know that by analysis, I need to have a 1 here and a 1 here. It means in the first step, what I should do is I should put set equal to 1 for flip-flop 1 and set equal to 1 for flip-flop 2 simultaneously. When I have put both the values as set equal to 1, the output will be set at 1, and now I simply apply my test pattern or test vector at the primary inputs. So only one test pattern needs to be applied at the primary input to test my circuit now. Right? So we have removed the requirement of previous time frames by using the set reset lines. Right? दोनों फ्लिप फ्लॉप के आउटपुट पर स्क्वायर में हाईलाइट किया है. I need a 1. So directly I put set equal to 1 for both the flip flops so that its output is set equal to 1 directly, irrespective of the requirement of putting C equal to 1 in previous time frame. So I can have this, only a single test pattern will be sufficient enough for me to check for the circuit, to test the circuit. Right? Only thing that I added is I need to add this set equal to 1 in the previous time. Right? Not exactly time frame, क्योंकि पूरा circuit analyze नहीं करना है. It is only this flip flop which needs one clock pulse and the things will be done. Right? But the problem is I need to have these setting, set equal to 1 के साथ साथ मुझे reset equal to 0 भी करना पड़ेगा. So दो flip flop है, so 4 pins need to be set, put the value. So I have increased the number of pins. जितना ज़्यादा number of pins होगा उतना मेरा area ज़्यादा बढ़ जाएगा, because I have limited area for an IC. I cannot implement so many pins at the output. For each flip flop I cannot add 2 pins. So the solution was scan chain. So now I have TC as the test control and I have scan in at input. When I have this scan in, the flip flops are connected in the form of shift register and I simply get the output from here. This becomes my scan out. Right? Now I required 1 and 1 here. So I'll just put this, test the flip flops first. I'll put the TC in 0. If TC is 0, scan data will be considered. TC equal to 0 पे scan data आता था कि TC equal to 1 पे? TC equal to 0 पर scan data आता है. So my scan data will be supplied from here. That data will enter. This will go into first flip flop. At the next clock edge, this will be transferred to second flip flop. Then I'll put TC equal to 1. When I put TC equal to 1, it is the data for this C which will now come in here. So I need again only one test pattern, just like the previous case. Only thing was I reduced the number of pins. Though flip flops hai still, but I added only one pin at input, another at output. That was very easy to work with. Scan in per, we have seen in the last class that the data is entered serially. So the only disadvantage that right now we are having for this scan chain concept is that we are having this data entered serially. तो जितने ये D flip flops होंगे उतने clock cycles मुझे लगेंगे. So if there are 10,000 flip flops, I'll need 10,000 clock cycles. But Still we are at an advantage because now this clock for the D flip-flop is independent of the way the input PI is applied. तो PI का क्लॉक अलग दे सकते हैं हम, और ये वाला जो D flip-flop का स्कैन इन वाला क्लॉक है ये हम अलग दे सकते हैं. If I increase the speed of this clock for shifting the data, I can reduce my time. Though 10,000 cycles may be required, but the speed may be very, very fast, so that data is quickly shifted in all the registers. So I can save that time. However, whatever be the case, I have certain overheads which I should consider when I have the scan design. The D flip-flop is generally implemented in the form of a master-slave. Master-slave तुमने digital में पढ़ा है. These are similar circuits connected as master and slave which run on opposite clocks. So if my master is running at clock equal to 0 or clock equal to positive edge, then the slave will run at negative edge. So that any change which master captures at the positive edge, that change will be taken up by the slave at the next falling edge. Right? So during one clock cycle, the data will be transferred, but with certain delay, so that everything can be settled down at the master level, so that slave can directly read it. So if I look at this structure, this requires 10 logic gates. On the top, I have shown a master slave D flip-flop which requires 10 gates. This is a normal flip-flop, normal D flip-flop. If I convert it into a scan flip-flop, I will add this multiplexer. When TC equal to 0, so this will be 1. So the lower AND gate will be transmitting the data. So scan data will be transmitted. If TC equal to 1, in that case the upper AND gate will be transmitting D, and therefore my data will be transmitted. So for each flip-flop, I have added 4 additional logic gates. So if my number of scan flip-flop is NSFF, N is number of scan flip-flops, then for each flip-flop I'll add more 4 gates, right? So more area will be consumed. The factor of overhead would be 4 times N, that is the number of scan flip-flop, divided by the total number of flip-flops into 10. Because if I had not implemented this mux, I would have required only 10 gates. Therefore, for each D flip-flop, I'll require 10 gates. So the total number of gates will be 10, number of for each flip-flop, plus some other number of gates which may be there. So NG. So the total gate overhead will be given by this formula, right? Not only gate overhead needs to be considered, we need to consider the area overhead. Area overhead means इतने मुझे logic gates extra लगाने पड़ेंगे, so that my area will be more consumed, right? The second overhead is performance overhead. Performance overhead means we measure the performance of the digital circuit or VLSI circuit in the terms of delay. So when I say we need to talk about performance overhead, we need to talk about the delay. Definitely अगर मैं flip flop के साथ 4 extra gates लगा रही हूँ, so the signal is being transmitted at least through an AND gate and an OR gate. So the delay of 2 gates will be added every time. चाहे मैं scan data दे रही हूँ, चाहे मैं D दे रही हूँ. Then every time the performance is expected to be lowered because an additional delay is performed. Secondly, the performance can be deteriorated further due to the long connections, right? The first figure shown here, this uses the standard cell layout which uses the normal flip-flop. Standard cell layout हमने पिछले साल पढ़ा था in VLSI, where all the cells are placed in one row. Each cell is of the same height but different width, and this is configurable. You are able to configure what cell does what, right? In between the rows of these cells, you have the routing channels where you can have the connections made horizontally and vertically only, right? You can again configure these rows of routing channels. So if I look at the first figure here, then certain flip-flops are implemented in one row and they are connected. Small interconnects are used. But look at the second diagram. There are so many interconnections made. The interconnection length gives you delay. We studied it in VLSI design. जितना ज़्यादा वायर लेंथ होगा उतना RC सेक्शन ज़्यादा होगा, उतना ही हमारा डिले भी ज़्यादा हो जाएगा. So now my output of since I am using the scan flip-flops, so the output of one flip-flop needs to be given as input to the next flip-flop, and so on. This will be input of the third flip-flop, and lastly I'll get some scan out. So the first thing that I do is I implement the basic logic of my D flip-flop, then add the multiplexer so that I convert it into scan chain. Then I perform the routing part. So that routing is introduced at the later end. The area required for the placement of the cells is still optimized. Only the delay will be major due to these wires, the extra wires. But these extra wires, these are utilized when we are testing for D flip-flop. Scan chain को जब हम test कर रहे हैं, circuit के लिए ये काम नहीं आ रहा है. Circuit के लिए तो ये जो normal connections है ये काम आ रहे हैं. So the circuit is working with lesser delay. Only the delay is caused during testing, which we can take care by increasing the clock speed for the scan in and scan out. Right? The third overhead, okay, we talked about performance overhead. So area overhead and performance overhead. Those are the two problems that we need to always tackle. However, the best solution available to us is scan chain. Now, moving on with the concept of scan chain as the standard. Why do we need it as a standard? Suppose I have a PCB. On a particular PCB, whenever I am having a system being made, I may have multiple ICs placed on the same PCB. Different sizes, different configurations, different number of pins, different manufacturers, everything may be different. But when they are used on a particular PCB to work out for a particular application, I need to ensure that if they are connected together, they should work properly. So now the requirement is that if I have a system which is accessible through some input-output ports, all these ICs on the system, they should work together, and I should be able to test the interconnects between these ICs as well. Not only the independent IC. जब तक वो IC अलग है, बोर्ड के बाहर है, fine, it is tested. But once it has been used on the board, I should again be able to test कि बोर्ड पर लगाने के बाद उसमें कोई प्रॉब्लम तो नहीं आया. So for that, the boundary scan standard was developed in 1990s and it is now referred to as IEEE 1149. Point 1 was the first standard version. Now we have point 4. This is also referred to as JTAG, Joint Test Action Group, because this was the action group which was working on this system of developing some standardized methods so that different manufacturers can have their ICs working compatibly. So for that, what this standard said is that whenever the IC chip is fabricated by any manufacturer, make sure that outside the chip you have a wrapper developed. So this standard introduced a wrapper. Wrapper is simply like किसी चीज को हमने किसी wrapper में, टॉफी को हमने wrapper में roll किया. So that wrapper has some specific requirements which always need to be met. Takan, you can put this on. This is working so that you can see it on the board. नहीं, पास वाला है on. हाँ ये वाला. हो गया? So now this, according to this standard, every manufacturer has to develop a wrapper around his design. Because उसने ठीक है circuit को test किया है. Every manufacturer tests for his IC. But what method he has used for testing, whether he has used set reset pins or he has used the scan chain method, what method has been used, that may be different, right? Therefore, each manufacturer develops a wrapper. The development of this wrapper is quite easy nowadays using a software. It is a one command thing, right? You just give one command and the design can have a wrapper developed on it. Right? The wrapper looks something like this. Okay. The wrapper has all the interconnections. जो मेरा board का input output pins है, these are connected to the wrapper. Say my signal goes to first IC, IC1, right? Then the connection of IC1 is to IC2. Now this wrapper should have the ability to identify if the testing is required to be done for IC1 or not. Agar IC1 is to be tested, it will directly take the signals inside IC1. If not, it has to bypass it so that the signal goes to IC2. Then IC2 will analyze. If the signal is made for it, it is required to work on it, then it will take up or work according to that signal, or else it will bypass it to the third IC. And so the cycle will continue and I'll get one output. This is the same concept as we did for scan chain. What scan chain did was, it gave one input, shifted it into a D flip-flop, then at the next clock edge, it shifted it to the next, shifted it to the next, and finally took an output. So the concept is basically developed from scan chain method only. Now the main thing is this wrapper. When I have this wrapper made, this gives me an advantage that my testing becomes hierarchical. It follows hierarchy. I can test this, I can use this to test an IC on a single IC on my board. I can use it to test the board completely if all the parts are working together or not. Moreover, I can connect it from one board to other boards as well. Iska output of one board is made input of the second board, and the output of second board may be made input to the third board. So I can test IC on the board. Moreover, I can test one complete board, and even I can have multiple boards connected in series because the data is traveling in series. All the input is given in serial sequence, right? Just like your scan flip-flop. Also, this gives me ability to test interconnects between ICs on the board. I'm able to detect any error if it happens here. That will also be checked, right? To do that, my wrapper needs to have boundary scan cell. This is most important thing. Boundary scan cell is simply a cell which is developed which connects every input output pin of my internal logic to the outside world, right? This is some input output, either be input bhi ho sakta hai ya output bhi ho sakta hai, but every pin needs to be connected to the outer world through a boundary scan cell. We call it boundary scan cell because this works as a scan register and is always placed at the boundary of my internal logic, so that I form a connection serially here. Each boundary scan cell needs to have 4 lines. ये तो हो गया उसका इनपुट लाइन, यहां से कुछ डेटा आया, that is given in here. If that data is required to be used by the internal logic for IC1, that data travels here. तो एक हो गया मेरे scan cell का output, which is now given to my IC, right? Then I should be able to use it as a scan register as well, so that I can test for the interconnects. So for that, there are 2 pins more, the lower end and the upper end. Lower end will enter the scan-in, it's a form of scan-in, and the upper pin will be a form of scan. So I can give my data to the IC directly. I can use it as a scan register if I propagate in this direction. Also, there is a flexibility that the data input can be given as this output as well. We'll look into the structure of this scan cell in a few minutes. Right? Now, all the instructions are given through this tap controller. This tap controller is basically these pins. This controls the testing. So what it does is I give the instruction, whatever testing needs to be done, that instruction goes to the instruction register, which stores what instruction needs to be done, and in turn settles the requirement for each IC. If the instruction says that it is to test IC2, it will set the mode of IC1 to bypass the signal and mode of IC2 as to test or use that signal. Then IC3 again bypass, IC4 again bypass. So that will be set according to the instructions. Also, there are some other registers to set this data. Fine. 5 important pins are shown here. Star means optional pin. This is test reset. This is optional. But 3 most important pins need to be there. Test data input, right? Test data output and test clock. Clock चाहिए ही हमें, input output होना ही चाहिए, and this TMS is test mode. Test mode select. What mode I have required to select. We see why we need this test mode. Reset करना है नहीं करना है वो अलग बात है. Now we look into what this boundary scan cell looks like. A boundary scan cell has 2 multiplexer and 2 D flip-flops, such that if I talk of this multiplexer and I set it mode equal to 1, remember the structure? One possibility is I need to have some input given to my scan cell which needs to be given out to my logic or IC, right? Then I may require to have a scan in, which I now call S in, and this is my scan out. So if I want the data to be transferred from input to output, I set this mode equal to 0. जैसे ये mode equal to 0 होगा, the in value is passed on to out. So direct transmission happens, right? We call this mode as normal mode. The normal mode of operation means you set mode equal to 0 so that whatever is at input, it directly goes to output, right? Second is scan mode. I want to use it as a scan register so that shifting can happen, and before testing I can shift the data. So for that, what I need is I need to have some data applied to this SIN, the lower pin, right? ये data कब read होगा? जब इस multiplexer का input is 1. So I need to put shift DR signal equal to 1. When this shift DR equal to 1, the data from SIN will be read by this multiplexer and not this input data, which will be passed on here at the input of my D flip-flop. Now at the clock cycle, when I have the clock DR as the positive edge, the data will move into the D flip-flop so that I can read that data at S out. Right? तो scan करने के लिए मुझे क्या करना है? I have to put shift DR equal to 1 so that the input data is not considered and only the scan in is considered when the clock edge occurs. Right? So I have my data transmitted from in to out, fine, from scan in to scan out. Right? Now the third mode is called capture mode, where the other flip-flop comes into picture. Sometimes it is required to move this SIN data towards output here. In this case, I need to capture this data into another flip-flop so that if any change happens here in scan data or in the data, that does not affect my output, which needs to be pushed towards output, right? Because जब हमने last class में देखा था, then we said कि output is observed, the scan out is observed, and at the same time you were inserting the next state. क्योंकि आपने TC equal to 0 किया था, if you remember your block diagram with the shaded area, you observed the previous cycle of shifted values and you at the same time inserted the new values. So both the things were working simultaneously. So if you are shifting new data, the old data should not be overwritten. So I use this capture mode. So what do I need to do for the capture mode? When update dr equal to 1, that this clock is equal to 1, the data will be transmitted or shared to this QB, and then as soon as I have mode equal to 1, this data will be transmitted towards output, irrespective of my D primary inputs, right? This is called capture mode. So what we are doing is whatever data QA had, that data moves to QB and finally moves to output. So I have completed this part. Scan in goes to out, right? And in between we did some update so that the data is stored here, right? This is how your boundary scan cell works. You can simply transmit the data in either direction. अगर FPGA पढ़ा है तो something like this we do for routing. We make connections. The router has the connections like this, so that your data can be transmitted here. If you want the connection to be made in this way, then you need to make the fuses blown in such a way that this connection works. So something like that, but we are controlling it using different inputs, right? How this scan cell can be used to test the different things. The first kind of test that we do is the external test, which we call X test. This is used to test the interconnects. Suppose I have two ICs. This is IC1. This is IC2. 3 instances have been copied. Basic structure is इतना. एक IC ये रहा, एक IC ये रहा. दोनों के ऊपर रैपर लगा हुआ है. Wrapper में other registers, scan registers, and everything is there. If I want to test the interconnect, what I need to do is I need to put my shift DR on for the first IC. उससे क्या होगा मेरा scan data? If I put this shift DR on, the scan data I can enter. This scan data needs to be given out at S out, right? तो उसके लिए मैंने क्या किया? Shift DR equal to 1. Then as soon as I'll have clock, I can read that data at S out. So I put this shift DR equal to 1 for these scan cells, so that ये जो मेरा data ये पहले scan cell पे गया, at the next clock edge it is seen at its S out, then it comes as input to the next scan cell, then at the next clock edge it is passed on. So as many number of cycles of clock will be required जहां तक मुझे interconnect को test करना है. So I have 6 here, 7, 8, 9. So I'll work for 9 clock cycles and will be able to shift my data from here to this scan cell. At this scan cell, I have this interconnect which needs to be tested. Right now, I am not entering into the circuit. I simply need to test the interconnect, nothing about the logic of the circuit. So I used it as a scan chain and transferred my scan data to this scan cell here. Now, I will pass on this scan in output, scan in value for the scan cell towards output, the third mode. Yeah. मेरा scan in जो मिल रहा है मुझे scan cell का, that I need to pass it to out. So what I do is I update the DR for chip 1 so that the data is transmitted, and for chip 2 I use the capture mode, that is I start saving the value in QB, right? So मेरा यहाँ से signal गया, it reached the other scan cell, उसके input पर आया ये, ठीक है? अभी मुझे क्या करना है, इसको output पे read करना है. So now I should again use the scan cells in the shift mode and observe the output towards the end, right? So I'll use the shift DR mode for chip 2 now. Chip 1 is not working at this time. So at the chip 2, I'll shift the value in the scan cell, and finally I'll read it at output, TDO, test data output. If the test data output is the expected value, it means this interconnect was working fine. If the value is not the expected value, it means there happened some error at a particular interconnect. We can test for multiple interconnects as well. एक इंटरकनेक्ट ये हो गया, दूसरा इंटरकनेक्ट ये हो गया, वैल्यू यहाँ पे तो ऑलरेडी है. I just configure the mode of this scan cell and I can test this interconnect as well. So multiple interconnects can be tested. This is the first test mode. The second test mode is the bypass mode. Bypass mode means कि उस IC को has nothing to do with that, ना scan register की तरह करना है use, ना उसको टेस्ट के लिए, लॉजिक टेस्ट के लिए यूज करना, but it should just bypass. So for that there is a bypass register dedicatedly given. The instruction register reads the instruction and sets the mode that this bypass register or this D flip-flop is set to pass the signal, and it will not allow the signal to pass through this scan chain or scan cell chain, right? Directly ये enable हो जाएगा ये वाला register, and whatever TDI test data input I have, it will directly be passed on to TDO. अगर हमें इसके through pass कराना होता, pass इसके through भी हो जाएगा, but that will add unnecessarily delay because the data will only be shifted at the clock edges. तो अगर यहाँ पे मेरे पास 12 scan cells लगे हुए हैं, so at least 12 cycles will be required to move through all these scan chains, then move to this mux and get the output, which is a waste of time. So directly a dedicated register is required here, which will be enabled only according to the instructions received by the instruction register that can set the mode, right? Then comes the in test. In test means you are required to test the particular IC. Again the same thing, you put in the test data input, your register, the instruction register reads that this is now required to go to a particular IC. So what it sets the mode of these scan cells, right? पहले scan cell को normal scan chain की तरह किया. Suppose your data is required to be supplied to this primary input, तो हम directly यहाँ से नहीं देके, we are going it through a test data pin. So I set the scan cell such that S in goes to S out for the first cell. Similarly, S in goes to S out for the second cell, and for the third cell, S in goes to its out pin, right? So now when it goes to out pin, it is now available for this IC to be used, right? पिछले किसी केस में IC के पास नहीं पहुंचा था, अभी now it is available for this IC. So now this IC performs the test, जो भी primary input से उसको test करना है. Then the output will be generated at a particular pin. This becomes input to this scan flip-flop, the scan cell. This scan cell will now shift the data to the rest of the scan cells at the boundary and finally give me the output through the mux. So different modes have been used. सबसे पहले shift DR mode हमने use किया है, so that the data is shifted and reached the required scan cell. So at least 4 clock pulses must have passed. Then the data reached the logic IC, right? Then I used update mode. Update mode means the data which has been read as S in gets captured by QB and the value gets updated, which is then passed into the IC, the internal logic. Then capture DR, the data is read at output or input of my next scan cell. And finally again shift karna hai, so shift DR mode. So again the data is shifted and at the output through multiplexer I can read my data. Right? This is the different way. We can have other tests as well. Right? जो internal registers हैं उनको भी test कर सकते हैं, but definitely we are not going much into details. Only the concept required is how to get the standardization done. IEEE 1149 is the standard which develops this wrapper. This is constant. This is same irrespective of the manufacturer for the IC. Everyone has to develop this wrapper so that we can test multiple ICs connected together. Extra pins की जरूरत नहीं पड़ेगी. Otherwise, if each IC needs to have multiple pins, we can have 64 pins on one side at least. So 64 into 4, that many pins should be available. इतने तो मेरे primary inputs ही हो जाते हैं, input and output. So it is now a question mark where to have those testing pins. So in order to avoid that, we use these wrappers so that no extra pins will be required on the IC for testing purposes. However, there are certain built-in test mechanisms which may be developed, which may be present in those IC, but we'll deal about those bit later. Right? So till here is your syllabus for sessional examination. Right? This is the only part which is conceptual. Certain methods are explained here. Rest everything is in a form of numerical. So you need to practice for that. So from the next class, we'll do a few questions so that you prepare for your sessional examinations. Right? You need to prepare well for your sessional examinations, though you have the option for second sessional. But the marks that are here, according to those marks for the first sessional, you will be required to take extra classes, which they have termed as something remedial class. If your score is less than the average marks of the class, remedial class needs to be taken by you. So we'll better score well. Right? That is all for today. You may leave.
Ma'am.